Numerical 3, this had appeared in April 2017 question paper for 6 marks. Okay, let us start solving this. A rectangular column of 300 by 450 mm carries a vertical load of 600 kilonewton at an eccentricity of 120 mm in a plane bisecting the depth of 450. So it is bisecting the depth of 450. So it means that if I mark this xx and yy axis, it is bisecting the depth 450. So it is here, it is bisecting the depth here. So this is going to be 120 mm. So E is 120. That means this load P is acting at distance E from yy axis. It means that the load, okay, load is something like this, axis is like this, and it is rotating about this axis. Okay, it is rotating about this axis. So about yy axis, rotating about this. Okay, so let us solve further. Find maximum and minimum combined stresses. So what we have to find? F max and F minimum. Formula is same. F max is what? F max is FA, that is axial stress plus bending stress, and F minimum is axial stress minus bending stress. So let us calculate first step, axial stress FA, okay, which is P divided by area. So this is equal to load 600 kilonewton. I am converting that to Newton, that means in 10 into 10 raised to the power 3 divided by area. Area of the section is 300 by 450. So this we get, the value is, this is 4.44 Newton per millimeter square. This is in Newton, this is millimeter, this is millimeter. So we get Newton per millimeter square. Second one, bending stress. Bending stress FB is equal to M by Z. So what is M? M is P into E. What is P into E here? Load 600 into 10 cube, that is load, into eccentricity 120. So 600 into 120. This is 72 into 10 raised to 6 Newton millimeter, because this is moment. Okay, what is Z? Z is I divided by Y. So to calculate I, which I we are going to take? Is it BD cube by 12 or DB cube by 12? It will be DB cube by 12. Okay, because it is parallel here. The moment is about y axis. So it is IYY, which we have to calculate because moment is about YY axis. So IYY will be dB cube by 12. dB is 450 into 300 cube by 12, and therefore y is 300 divided by 2. This is 150 mm. Let me calculate this value. Get 1.0125 into 10 raised to 9 millimeter raised to 4. Okay, so now we have to just substitute there. What is Z value? I by Y. Okay, so this is I by Y by Y. So 1.0125 into 10 raised to 9 divided by 150, which is equal to, divided by 150. So we get 675.0000 millimeter cube. Okay, mm raised to 4 divided by mm, so mm cube. Okay, so finally bending stress is equal to 72 into 10 raised to 6 divided by 675. Okay, so 72 divided by answer into, so we get 10.67 Newton per millimeter square. This is bending stress. Now let us calculate maximum pressure intensities. that is F max, which is equal to FA plus FB. So we have 4.44 plus 10.67, 4.44 plus 10.67. Here we have 15.11 Newton per millimeter square, and F minimum is FA minus FB, which is 4.44 minus 10.67. This is minus 6.23 Newton per millimeter square. So since this is plus, this is compression, this is minus, so this comes in tension. That means what? The load is lying outside the core or corner of the section. So let us plot this now. How we are going to plot this? I'll plot it right below this. Okay. Okay. Or I can do it here. This will be a better place. Load is here. Okay. So that is why, since the load is towards right of y axis, so this is FA plus FB, that is F max is on the right side. So whatever value we have got, 15.11, should come this side. Okay, because the load is on the right side, that side it will be plus sign, and this will be minus, so it goes in tension. So this is like this, and this is like this. This is plus, this is minus, and this is 6.23. This is your stress intensities. So done.